Alright, so in this video, I am talking about the psychrometric chart. So the concept behind the psychrometric chart is to get rid of all those calculations that we have done to find the properties. Like the calculations that we did are very typical in the industry, particularly for the application of air conditioning design. And we as engineers, we really want to avoid doing lots of calculations. They can be easily error prone. So because of that, we are using the psychrometric chart. The concept behind the psychrometric chart, before I show you the chart, is pretty simple. We have, let's say, if this is the overall geometry of the chart, we have all different properties in different directions or different axes, if you will. So let's say this is the overall shape of the chart, the psychrometric chart. Here in the horizontal axis, we have the dry bulb temperature, TDB, the dry bulb temperature. All right. In the vertical axis on right, we have the absolute humidity, or the other name is humidity ratio, and we show that with omega. Okay. The unit of absolute humidity is either gram water vapor per kilogram dry air or kilogram water vapor per kilogram dry air. The unit that we have in our table is based on kilogram. So kilogram water vapor per kilogram dry air. Okay. Now in these axes, or in this curve thing, we have the relative humidity. So let's say this curve shows for relative humidity equal to 100%. So the constant relative humidity lines are, let's say, starting from here. Maybe I can show them with dashed lines. So this is one constant relative humidity, and as we go in this direction, the relative humidity increases. So for instance, this can be relative humidity 10%, and another line like this can be relative humidity of 20%. And this one can be relative humidity of 30%. Okay, and as I said, like going in this direction, the relative humidity increases. All right. Now, in addition to the absolute humidity and the dry bulb temperature and relative humidity, we have some other properties. The other property that we have on this chart is the specific volume lines, or constant specific volume lines, which are in this orientation. So the red lines here are showing the direction of specific volume lines. I'm just showing that in different colors to make it easier to see. Okay, so let's say they are V constant lines. So we definitely go to the table after this, and I will show you in the table. The other pattern of the lines that we have are enthalpy lines, which are kind of in parallel to the V constant lines. So let's say, for example, I can show them in black. Let's say the black thing is the H lines. So we have lines in this orientation or this direction, and they are H constant line or enthalpy constant line. H is the enthalpy. All right. And also we have dry bulb temperature. You know what? Because this figure is pretty crowded, I make another one and I show you here. So let's say this is the chart. Let's say this is the V constant line. Another pattern of lines which have pretty much less slope are H constant line, and another patterns of line is the wet bulb temperature. So this is the wet bulb temperature, this is H, and this is V, and you will see them in the figure. Okay, now the way that the psychrometric chart works is you need to have two properties to find your point. Okay, so let's say you have the property on the horizontal axis, which is the dry bulb temperature, and you have, for instance, you have the relative humidity. By combination of those two, you find your point on this chart, and depending on the property you're looking for, you follow the constant property lines to find that value. Okay, so once again, let's pretend that I have the relative humidity and I have the dry bulb temperature. So let's say this is the dry bulb temperature that I have, TDB. And for instance, the relative humidity temperature that I have is 10%. So let's say this dashed line is relative humidity of 10%. So the combination of these two gives me this point, and this is the point that I want to use to find other properties. For instance, if I'm looking for H, I want to find or follow the H constant line in this orientation, and etc. Let's say if I'm looking for V, I want to find the corresponding V line. I think it's much easier if I show that on the chart. So let's go to the chart. So the chart that we have in our tables is A31. Okay, so this is the chart that we have. Here you see it says figure A31, psychrometric chart for 1 atmosphere total pressure. Okay, so this is the pattern of the chart that I was talking about. On the horizontal axis, we have the dry bulb temperature. Here, I'm not sure if we can read, but here it says humidity ratio or omega, and the unit is gram moisture per kilogram dry air. That's the unit. If you cannot see these, just use your own table. These lines are, let me show them with a pencil so you can follow easily. So this line is the relative humidity line. I'm pointing at 10% relative humidity. This is 20% relative humidity, the green line. This is 30% relative humidity. Here it shows 30%, 40%, 50%, all the way to this one here, which is for 100% relative humidity. So this line, this green line, is 100% relative humidity. Before that, we had 90% relative humidity. These are the enthalpies. So the enthalpy lines are shown with solid line. You see this solid line? This is the enthalpy of 70 kilojoule per kilogram dry air. The unit is very important. 70 kilojoule per kilogram dry air. 80, 90. This is the like these things here, they are the saturation temperature. I will discuss about that later, but basically the temperatures that we see here, they are the dew point temperature. I will discuss about that specifically for dew point. What else? The other thing is, you see here it says wet bulb temperature. So these lines, this is the orientation of the wet bulb temperature. For this particular one, I'm pointing at 25 degrees C wet bulb temperature. The other wet bulb temperature line that I have is here, 20 degrees C wet bulb temperature, 15. So the wet bulb temperatures are shown with dashed lines, or are shown with dashed. Okay, so let's say 25 degrees C, 15 degrees C, and 20 degrees C. And between 20 and 25, for instance, there are 3 dashed lines or 4 dashed lines. So this dashed line is for 21, 22, 23, and 24. What else? The other thing that we have here on this chart is the V value, or the volumetric volume cube meter per kilogram dry air, or specific volume basically. Okay, so this direction, this line, let's say this orientation, is our specific volume lines. I'm showing the orientation of a specific volume lines. This one here is 0.92. This one here is 0.94. So specific volume lines are shown with solid green lines, and that specific volume comes down, let's say, to 0.9, 0.88, 0.86, 0.84, 0.82, 0.8, 0.78 meter cube per kilogram dry air. Okay, and we should have one more property, I think. So we did this one, we did relative humidity, we did specific volume, and also this was the enthalpy. I think we covered all the properties. Now, I want to talk about, as I said, about the temperature, the dew point temperature. So for dew point temperature, what you want to do, you want to go horizontally to the left, all right? The reason behind that is for a given point, we want to decrease the temperature, which is this horizontal axis, until we have saturation or we have 100% relative humidity. So to obtain the dew point temperature from your point, let's say this is your point, you are going horizontally to the left and you are reading that particular temperature. So let's do one example together and get the properties from this chart. So let's say in the example that I have for you, we have these combinations. So let's say I have temperature of 30 degrees C and 40% relative humidity. For part A, I want to find specific volume. Yes, you can definitely use the equations, no doubt about that. But that is just time consuming. We simply can get them from these charts. So why not doing that? So one quick tip for you. The temperature that is given is always the dry bulb temperature, unless they specifically mention the wet bulb temperature. But whenever they say nothing, this is the dry bulb temperature. So be aware of that. So this is the procedure. What I'm going to do, I'm going to find this point on my psychrometric chart, temperature of 30 degrees C. The horizontal axis is the temperature. So you see it's 20 and 30 degrees C, and here it says the dry bulb temperature. This is exactly what you want to use. And for relative humidity of 40%. So let's say this is 10%, 20%, 30%, and 40%. So my point is somewhere on this vertical line and somewhere on these 40%. In fact, I do have the point here. Okay, so let's say this is my point. This point has the dry bulb temperature of 30 degrees C and relative humidity of 40%. In part A, the question was asking for the specific humidity or absolute humidity or humidity ratio. All of them are the same thing. So once again, the specific humidity or absolute humidity or humidity ratio are all omega. All of them are the same thing, just with different names. Now, I know that the specific humidity is shown here on this vertical axis. Here it says humidity ratio or specific humidity. Both of them are the same thing. So that means I want to read the vertical axis on right. So what you want to do, once you find your point, you want to go horizontally to the right and read that value. So let's say if this is my point, if I go to the right, now I need to read between 10 and 12. It is here, it's closer to 10, and the value I have is 10.5 gram, where is it? Gram moisture per kilogram dry air. Be careful with the unit, okay? Now, just be careful. When you go to the right column, there are two series of numbers. One of them starts from, let's say, 2 to 30, and the other one starts from 50 and to 120. So the larger range of numbers, they are in fact enthalpy. You see here, for instance, this is 70 kilojoule per kilogram Kelvin, and here is also 70. You have 80 here, you have 80 here, you have 90 here, you have where is it, 90 here. So on the right axis, the greater range of numbers, they are enthalpy, and the smaller numbers, they are humidity ratio. In part A, I'm looking at the smaller range. So the answer to part A, going back to the problem, is 10.5 gram H2O or moisture over kilogram dry air. So very schematically, if I want to show how I found this is how I found this number. I found my dry bulb temperature of 30 degrees C, and I found its junction with 40% relative humidity, and after that I horizontally moved to the right, and this is where I found my omega. So that is answer to part A. In part B, we want to find enthalpy. Okay, so again, going back to the point. So this was my point, and enthalpy is shown here. You see the orientation of enthalpy lines, like these solid lines are the enthalpy. So that means I want to go, this is very important. This time you are not going horizontally to the left. You are in fact going diagonally to this column. So this is the orientation you want to go. All right? So don't go crazy. Just do your best to find that. I would say probably around 58 is the enthalpy. So H is 58 and the unit is very important. Kilojoule per kilogram dry air. So for part B, this is what I did. This was my point. This time, the orientation that I did or the travel that I made was in this direction, simply because I was going parallel to H constant lines. This is really important. Okay, now in part C, the question is asking for the wet bulb temperature. I think wet bulb temperature is probably the easiest because we do have wet bulb lines. So this is 25 degrees C. Let's say this is 25 and this is 20. And you know what? In fact, our point is exactly on 20 degrees C of wet bulb temperature. So my wet bulb temperature is 20 degrees C. It's right on that wet bulb line. In part D, we are looking for dew point temperature. Now, as I said, for dew point temperature, this is what you want to do. Let's say this is the psychrometric chart. This is your point. You want to go horizontally to the left to read your dew point temperature. And the reason behind that is in dew point temperature, the concept is to obtain the temperature at which the condensation occurs. All right. And in that concept, we are not really changing the moisture content, which is the vertical axis on right. So we shouldn't really change or go in vertical direction. We should keep the vertical direction the same and go horizontally to the left, because by going to the left, we also decrease the dry bulb temperature. We reduce the temperature of the mixture. So if this is my point, right, you want to go horizontally to the left and read the temperature that you have here. So I would say for this point, if I go to the left, you see here it says 15. We are actually very close to 15 degrees C. So I would say our dew point temperature is 15 degrees C. So this is dew point, dP. In part E, the question is asking for the specific volume. So this schematic was for the dew point temperature, by the way. For a specific volume, again, I think specific volume is another easy property because the constant property lines are shown. So this is the orientation of the specific volume. All right. You see it says volume cubic meter per kilogram dry air. So this is 0.92, 0.9, 0.88. The next one is 0.86 and this is 0.87. I'm referring or I'm pointing at the solid green line. So we are between 0.87 and 0.88, but we are closer to the 0.87 line. So I would say our V or specific volume is 0.872 meter cube per kilogram dry air. All right, so finally, I have a comment or a tip for you, and the point is for saturated air, right? The wet bulb temperature is equal to the dew point temperature is equal to the dry bulb temperature. So whenever the air is saturated, meaning that whenever the relative humidity is 100%, these three temperatures are the same. Let me show you on the chart before going to the chart. So once again, this is the wet bulb temperature, this is the dew point temperature, and this is the dry bulb temperature. And let's see why that happens. So as I said, this line, this green line is for relative humidity equal to 100%. Let's focus on temperature of 20 degrees C, which is right this point. So this point, if I want to find the dry bulb temperature, I need to go horizontally down, vertically down, and that is my dry bulb temperature. You see it says 20 degrees C. Now, so I see that for a dew point temperature, the dry bulb temperature is also 20 degrees C. The other one that I want to read is the wet bulb temperature, right? So this is the wet bulb temperature 25, 24, 23, 22, 21, and 20. You see here, again, my wet bulb temperature is 20 degrees C because that's on this slide. So long story short, for relative humidity of 100%, the dew point temperature, the dry bulb temperature, and the wet bulb temperature, which is in this orientation, they are all the same. So for those of you who are ending up in the HVAC industry, you are going to use this chart a lot. Okay, so this is the chart that they are using in real life and industry. They are using the psychrometric chart a lot.